Today we're going to tackle the op amp, and we're going to try to make our own using discrete components. The op amp is such a versatile circuit that at its core it's an amplifier, inverting or non-inverting, a buffer, or a comparator. It could also do mathematical operations like add, subtract. This is what the voltage is. It can differentiate, it can do calculus, it can integrate, it could perform a logarithm as seen in my last video, and it could perform an exponential function. It could even do more complex things like make an oscillator or even make a sine wave generator using just a handful of external components. Let's see how it works. So for those of you who've ever wondered how an op amp works, I have the circuit here. Basically, to make an op amp, the bare bones op amp, you need four components, four transistors. Two NPN transistors to generate a differential amplifier, as you can see on the left side of the screen. They should be sort of closely matched, and a current source, which is a 10K resistor, and then a voltage gain stage with a push-pull amplifier using a PNP and an NPN transistor. So let's put that together. I'll show you the circuit on the breadboard. And basically, this is powered with positive 12 volts. All the red wires are positive 12 volts. All the black wires are negative 12 volts. And it starts out with these two 2.2K resistors that are supplying voltage to two NPN transistors. This is a differential amplifier. The output of that is going through this large 10K resistor to negative 12 volts. So the input of one differential amplifier is going through this 2.2K resistor, and the input of the other one is going through this other 2.2K resistor. So basically, this is going to be the non-inverting input, and this is going to be the inverting input at that point. The output comes out of the right-sided BJT, and it's going through another 2.2K resistor to this PNP transistor, which amplifies it, causes a little bit of a gain, and using another NPN transistor, it further amplifies it to the final output, which is going through this yellow wire and being monitored by this oscilloscope probe. The other oscilloscope probe is monitoring the input voltage. So let's test it out. So here's a picture with all the components labeled as I just described them. So let's test it out by first making a very basic op amp circuit, the buffer. Connected the output through this black wire to the inverting input, and this is basically the op amp based buffer. So if I was going to zoom out, the input is going through this 100K potentiometer wired as a voltage divider and going through this white wire into the non-inverting input. So whatever voltage comes in on this is wired between positive 5 volts and negative 12 volts, just for fun. And so let's see what the oscilloscope reads when I turn it on. So the yellow tracing is going to be the input voltage, and the blue tracing is going to be the output from this. So as I turn this, it follows nicely all the way down. Okay, so that is the voltage follower, the buffer. For the next test, we're going to try to configure this as a comparator and see if it works. What I've done with this black wire is connected it to ground, and that's going to the inverting input, and the output is basically coming out of here. And so what this is a comparator circuit. So let's turn this on and see how it goes. So if the voltage, the yellow tracing is the input voltage, I have it on different scales. If it goes up beyond 0 point, beyond the ground point, it goes up and vice versa if it goes down. So I'm just twisting this potentiometer back and forth, and that is working well. There's a rail-to-rail output, and it goes between positive 12 volts and negative 12 volts. That's pretty good. Now let's see if we can make this amplify. So now what I've done is I've taken the output here from the DIY op amp, and I've basically taken the output and I've put it through a voltage divider here with a 100K resistor and a 100K resistor to ground, and that is going into the inverting input, and so this is going to be a non-inverting amplifier. So the parent signal is still coming from that potentiometer. So let's see how it looks when I turn it on. So as I rotate the potentiometer, you could see the yellow tracing is the input voltage and the blue tracing is the output voltage, and you can see there's a gain of about 2, which is the appropriate gain for something like this. Okay. And now we'll make an inverting amplifier with 10 times gain. So now what I've done is I've taken the inverting input and I'm going to put this to ground, and the non-inverting input. Then what I've done is I've taken this potentiometer, and the output of that is going through a large 10K resistor, through this resistor into the inverting input, which is there, and the output I have connected with a negative feedback loop through a 100K resistor. So now back to the inverting input. So now let's see how that looks as an inverting amplifier. Now the gain of this should be 100K over 10K and the negative of that. So it should be negative, it should be an inverting amplifier. So let's try it out. And you can see here, they're on the same scale. And as let me change the scale of the input voltage so we could actually see it. Right now they're on the same scale. Let me change the scale of the output voltage to very high, and input voltage I'm going to change to 500 millivolt divisions. So that's that. Now let's see as I wiggle this. You can see very small sweeps of the input give you an exactly inverting amplifier. It's an amplified signal. If I decrease the and you can see the resulting voltages. And it goes rail to rail. It's pretty good. So I think that works pretty well for a homemade op amp. So that is a TLO 74 right there, and so that's basically the same thing. It's an op amp that uses, and this is the usual construction of it. So this is how the inner workings of an op amp work. There's a differential amplifier stage. There is a voltage gain stage, and that's it. And that's how it works. Last one. Now I've changed that big 10K resistor to a 100K resistor. So this is an inverting to a 100K resistor. So this is an inverting buffer. So it's all going through the inverting input, and when these voltages on the oscilloscope are all to scale, and as I twist this back and forth, it basically produces the exact inverted voltage. It's an inverter, essentially. And that's how it all works. So overall, not that anybody needs to create an op-amp, but this is a great learning experience to see how an op-amp works. I'm going to leave you guys with the final schematic. Basically, this is not very practical, but definitely useful in learning how an op-amp works and how to make your own.